All right, in this section, we're going to talk about section 1.3, dealing with models and applications. Basically, we're just going to be dealing with word problems. So in this section, we're going to use linear equations to solve problems and solve a formula for a variable. You'll be given a formula. You just want to write that formula in a different way so that you can get the defined variable by itself. Now, on this screen, we do have a strategy for solving word problems. Number one, you want to read the problem carefully and assign a variable to represent one of the quantities in the problem. And then number two, you want to write expressions for any other unknown quantities in terms of x. And then number three, you want to write the equation in x that models the verbal conditions of the problem. And then number four, solve the equation and answer the problem's question, okay? So you don't want to just solve for the x. You want to make sure that you answer the problem's question. So that means whatever other expressions that you have assigned or written for other unknown quantities, you might have to use that in order to answer the problem's question. And number four, you're going to check the solution. And what I mean by checking the solution, you want to check your solution using not the equation itself, but you want to use the original wording of the problem to make sure that your answer makes sense. Okay. So in this first example that we will look at is this. According to the U.S. Department of Education 2007 data, there is a gap between teaching salaries for men and women at private colleges and universities. The average salary for men exceeds the average salary for women by $14,037. Combined, their average salaries are $130,015. Determine the average teaching salaries at private colleges for women and for men. So in this case here, we do know something about the average salary for men. It exceeds the average salary for women by $14,037. So we don't know anything about the average salary for women. So we're going to start this problem by letting the x be the average salary for women. X will be the average salary for women. We do know that the average salary for men exceeds the average salary for women by $14,037. And the word exceeds means we got to add whatever the average salary for women to this amount, $14,037. So here, that will mean that X plus $14,037, that will be the average salary for men. All right. Now, we're also told in the next sentence, combined, their average salaries are $130,015. That means the average salary for women plus the average salary for men equals this amount. So when we write our equation, it's going to be this, the average salary for women, that's X, and then plus the expression for the average salary for men, that will be X plus $14,037. That will be equal to the amount, the combined amount, $130,015. So this is our equation that will help us find the average teaching salaries at private colleges for women and for men. So we're looking for two things here. So let's take this equation and combine some like terms here. This is 1x plus another 1x that will give me 2x. Then plus 14,037. That's equal to 130,015. So now to get the 2x by itself, I'm adding $14,037. I need to subtract $14,037. So that means 2x is equal to, now if I subtract $14,037 from 130,015, I will get $115,978. And then to solve for x, I'm multiplying by 2, so I need to divide both sides by 2. So that means x is equal to, in this case, $57,989. Now keep in mind, we let x be the average salary for women. So here, that x equal $57,989, that represents the average salary for women. And now for the average salary for men, because we're looking for the average salaries for women and for men. And this represents the average salary for men, that x equal $14,037. I mean, x plus $14,037. And since x is 57,989, we just substitute that value in for x. So we're going to add $57,989 to $14,037. And this will give us a total of $72,026. And that amount is the average salary for men. Okay. And if you want to check to see if that the answer makes sense, if we add those two amounts, you should end up with $130,015. So the average salary for women is $57,989, and the average salary for men will be $72,026. Okay. All right, let's look at the next example here, example 2. The freshman class of 2006 was less interested in developing a philosophy of life than the freshmen of 1969 had been. In 1969, 88% of the women considered this objective essential or very important. Since then, this percentage has decreased by approximately 1.1% each year. If this trend continues, by which year will only 33% of female freshmen consider developing a meaningful philosophy of life essential or very important? Okay, so now we need to look at the number of years after 1969, because that was the year that 88% of women considered the objective essential or very important. Okay, so let's let x equal the number of years after 1969. Okay. Now let's interpret this into an equation, because we were told in 69, 88% of the women consider this objective essential or very important. Okay, so we're starting off with 88. And here I'm just going to be using the whole number 88. I'm not going to convert the percent to a decimal. So we'll just say 88. And then minus, this percentage has decreased by approximately 1.1. Okay, well, it says decrease, that's why I put the minus there. And it's decreased by approximately 1.1 each year. So we need 1.1 times the number of years after 1969. 1.1 times X. And then we want to know which year we're only 33%. So this expression, 88 minus 1.1x, has to equal 33. So that's our equation that we're going to solve for x. All right, so I need to get negative 1.1x by itself. So in this case here, I have a positive 88. So the opposite of a positive 88 would be negative 88. So in essence, I'm going to subtract 88 on both sides. And when I do that, I'm going to bring down the negative 1.1x. That's equal to 33 minus 88. That will be negative 55. So I get negative 1.1x equal to negative 55. And then to solve for x, I'm multiplying by negative 1.1, so I need to divide both sides of this equation by negative 1.1. So x is equal to, now negative divided by negative is going to be positive, so that means 55 divided by 1.1 would end up being 50. And this is in years, by the way, because I'm letting x be the number of years after 1969. Okay. So 50 years after 1969, 33% female freshmen will consider developing a meaningful philosophy of life essential or very important. Now, if I add 50 years to the 1969, that would be 2019. So by the year 2019, only 33% of female freshmen will consider, I'm going to put this in quotes, developing a meaningful philosophy of life essential or very important. Okay. So that's how we will answer that question. Okay. Let's look at another example or another word problem like this one. You're choosing between two long-distance telephone plans. Plan A had a monthly fee of $15 with a charge of 8 cents per minute for all long-distance calls. Plan B has a monthly fee of $3 with a charge of 12 cents per minute for all long-distance calls. For how many minutes of long-distance calls will the cost for the two plans be the same? Okay. So we're looking for how many minutes of long distance calls. So that means we need to let x equal the number of minutes. We're letting X be the number of minutes. So in this case here, we're told that plan A. So I'm going to write here plan A. I'm going to write the algebraic expression for that. So it says here, plan A has a monthly fee of $15 with a charge of 8 cents per minute. So algebraically, I can write that as 15 plus a charge of 8 cents per minute would be 0.08 times X. That would be the algebraic expression for plan A. $15, a $15 monthly fee, plus a charge of 8 cents per minute, 0.08 X. Now for plan B. Has a monthly fee of $3 with a charge of 12 cents per minute. In this case here, a $3 charge is 3 plus a charge of 12 cents per minute, 0.12 times X. And again, X is the number of minutes. Now the question is, for how many minutes of long distance calls will the cost for the two plans be the same? So in other words, the cost of plan A must equal to the cost of plan B. Well, in this case here, plan A is 15 plus 0.08x, and that's equal to plan B, that'd be 3 plus 0.12x. So now we're going to solve this equation for X. All right. In this case here, let's try to get the variable terms on one side of the equation. And let's see here, I'm going to move the 0.08x over to where 0.12x is. Now I'll do that by subtracting 0.08x on both sides. And when I do that, I'm just going to have 15 on the left side. That's equal to 3 plus 0.04x. And now I need to get 0.04x by itself. So I'm adding 3, I need to subtract 3 on both sides. So here I'm going to have 12, and that's equal to 0.04x. And now to get x by itself, I'm multiplying by 0.04, so I need to divide both sides by 0.04. So that means x is equal to, okay, if you do this on the calculator, 12 divided by 0.04, you will end up with 300. Okay, so to pretty much answer that question, I would say this: at 300 minutes, the cost of plan A and plan B will be the same. Okay. So that's how we'll solve that equation. Solve that word problem. And you can pretty much check by substituting the 300 in for X for plan A and for plan B. The cost there should be the same. All right, next example. say we had something like this. After a 30% price reduction, you purchase a new computer for $840. What was the computer's price before the reduction? Okay. So here we're trying to find the original price of the computer. So we'll let X equal to the original cost of the computer. I'm going to let X be the original cost of the computer. Now, I'm going to show you two ways to solve this particular word problem here. Here's the first way. We know there's a 30% price reduction. Now, 30% as a decimal is 0.30. Okay. So in this case here, the cost of the computer will be X or just 1X. And we're doing a reduction, so we have to subtract 30% of the original cost of the computer. So it'd be 0.30 times X. And then that's going to be equal to the purchase price of $840. So now we want to solve this equation for X. Now notice I put the 1 in front because this is like $1 minus 30 cents. If you think of money, $1 minus 30 cents will be 70 cents. So 1X minus 0.30X will be 0.70X. That's equal to 840. And then to solve for X, we just divide both sides by 0.70. So here, 840 divided by 70, 0.70, I should say, will give you 1,200. So the cost of the original price of that computer before the reduction was $1,200. Okay. That's one way of solving this word problem. Now here's the other way of solving that word problem. I'm still going to let X be the original cost of the computer. But let's think about this. The original cost of the computer, that's going to be 100%. Okay. Because if you were to pay the computer without that reduction, then that means you're paying 100% of that cost. But now you're going to pay less than that. It's going to be reduced by 30%. So if we subtract 30% from 100%, you'll get 70%, which means you're going to only pay 70% of the cost of that computer. And 70% as a decimal is 0.70. And if you don't know that, you can just drop the percent sign, move the decimal point 2 places to the left, or since percent means per 100, you can take 70 and divide that by 100. So this would be 0.70 times the original cost of the computer, which is X. That would be equal to $840. And then next, divide both sides by 0.70. That will give you X is equal to $1,200. Okay. So here the computer's price before the reduction was $1,200. Okay. All right, now here's another example. Let's say you had a word problem like this one. You inherited $5,000 with the stipulation that for the first year, the money had to be invested in two funds, paying 9% and 11% annual interest. How much did you invest at each rate of the total interest earned for the first year or if the total interest earned for the first year was $487. Okay. This should be if. All right. All right, so let's look at this for a moment here. I'm going to let X equal to the amount invested at the 9%. So X is going to be some amount invested at 9%. That means what's left was invested at 11%. So that means $5,000 was inherited. So whatever was left of that 5,000, that would be 5,000 minus X. That would be the amount invested at 11%. Okay. Now, there's something that you do need to know about the simple interest formula. As always, I is equal to P times R times T, where I is the interest, P is the principal, R is the interest rate, and T is the time. Okay, now we're dealing with interest earned for the first year. So that means that T is equal to 1. Okay, T is equal to 1. So if I substitute the T with 1, substituting the T with 1, this is what I have. I is equal to P times R. Okay. So it's going to be the principal times the interest rate. So for this amount, X invested at 9%, I is equal to P times R. That would be this. 9% as a decimal would be 0.09 times the amount invested, which is X. And then for the second, I'm going to add to it the amount at 11% times 5,000 minus X. 11% as a decimal would be 0.11 times the amount invested, 5,000 minus X. So for each of these, I'm using I is equal to P times R, the principal or the amount invested times its interest rate. Oops, sorry. And that amount should equal to $487. So here's my equation that I'll be using. 0.09x plus 0.11 times the quantity 5,000 minus X equals 487. And now we're going to solve this equation. First, I'll use a distributive property to remove the parentheses and combine like terms if necessary. So in this case, I'm going to bring down the 0.09x plus distribute by multiplying 0.11 times 5,000. That would give me 550 minus 0.11 times X, which will be 0.11 X. That equals 487. And then the next step would be to combine like terms. If I do 0.09x minus 0.11x, this will be a negative, so it'll be negative 0.02x plus 550 equals 487. And now to get the negative 0.02x by itself, I need to subtract 550 on both sides. So now you got negative 0.02, x is equal to negative 63. And then to solve this equation for x, divide both sides by negative 0.02. That would mean x is equal to $3,150. Pretty much you just type in negative 63 divided by negative 0.02. Now that x equals 3,150, that represents the amount invested at 9%. That's the amount invested at 9%. And now to find out how much was invested at 11%. That's represented by the 5,000 minus x, which means I take 5,000 and subtract from it the 3,150. That will give me $1,850. So this represents the amount invested at 11%. Okay. All right, here's another example. The length of a rectangular basketball court is 44 feet more than the width. If the perimeter of the basketball court is 288 feet, what are its dimensions? So in other words, we're looking for the length and the width if we're to find its dimensions. And one way of visualizing this type of problem is to go ahead and draw a rectangle, because it does say a rectangular basketball court. So in this video, I'm going to go ahead and draw the rectangle for this example. Okay. Not the best looking rectangle, but it will work. Okay. Now, we know something about the length, but nothing about the width. So I need to let x equal the width of this rectangular basketball court. So I'm going to label this side and this side as x. And I know this because from my days of taking geometry and teaching geometry, that opposite sides of a rectangle, they're going to have the same length. Now, the length of the rectangular basketball court is 44 feet more than the width. That would mean that x plus the 44 is your length. So this is x plus 44 on this side, and its opposite side has to also be x plus 44. Okay. So now, let's look at this here. There's a formula for finding the perimeter of a rectangle. And that's going to be this. P is equal to 2 times the length plus 2 times the width. All right. So now let's do some substitution here. The P is your perimeter. We're told that the perimeter of the basketball court is 288 feet. So substitute the P with 288. That's equal to 2 times the length. This length is represented by x plus 44. So it'd be 2 times the quantity x plus 44 plus 2 times the width. We're letting x be the width, so it'd be 2 times x. So this is our equation where we're going to find the dimensions of the basketball court. So in this case here, let's do the distributive property by removing the parentheses and combining like terms if we can. So if I do 2 times x, that's 2x, plus 2 times 44, that's 88. And then 2 times x, that's just 2x. Combine like terms, 2x plus 2x is 4x. So I have 288 is equal to 4x plus 88. And then to solve for x, well, first I need to get 4x by itself. I'm adding 88, so I need to subtract 88 on both sides. So that means I'm going to have 200 is equal to 4x. And then to solve for x, I'm multiplying by 4. I need to divide both sides by 4. So that means x is equal to 50. Now I can write it like this, as x is equal to 50. And this is going to be in feet because the dimensions are in feet, by the way. X equals 50 feet. Well, we did let x be the width, so that means the width is 50 feet. Now we need to find the length. And we let that length be x plus 44. X is equal to 50, so substitute your x with 50. You have 50 plus 44. That will be 94. And that will be in feet. And this here is the length. Okay. So now our dimensions of this basketball court are 44 feet by, 94 feet. Okay, because our length is 94 feet. So that's 94 feet by the width, which is 50 feet. Okay. All right. Now, next we're going to look at solving a formula for one of its variables. So here we're going to be given a formula. So you want to rewrite the formula so that the variable is isolated on one side of the equation. Now, it does not mean we're obtaining a numerical value for that variable. We're just writing it in a different way so that one of the variables will be by itself. So like in this problem, we want to solve for the formula P is equal to 2L plus 2W for W. So in other words, we want to get W by itself. And I'll write this out. Sometimes you might see the variable underlined, meaning they're telling you to solve for the underlined variable. So in other words, we want to get W by itself. That means we need to move the 2L to the other side and get rid of the 2 that's in front of that W. So in this case here, let's move the 2L where the P is. That means we need to subtract 2L on both sides. So I'll have to write this as P minus 2L. Those are two totally different terms. I'm not going to be able to combine those. I just have to write it just like that, P minus 2L. And then that's equal to 2W. And I still need to get W by itself. It's being multiplied by 2, so I need to divide both sides by 2. That would mean W will be by itself, and I'm not going to be able to divide anything, so it's just going to have to remain like this. P minus 2L is equal to 2. So this is the formula that we can use to find out what the width is if we already know the perimeter and its length. So you just substitute the P and the L with those values, and that will tell you what the width is. Okay. All right, here's another example. Let's say we have this formula. P is equal to C plus M times C. And I want to solve that equation for C. So I'll rewrite this as P is equal to C plus M times C. Now notice here we got a C right here and a C right here. That means I need to use that as a common factor. I need to do some factoring here, okay, on the right side of this equation. So I'm going to bring down the P, that's equal to, well, C is in both of these, so that means I'll have to factor out the C, because C is going to be the common factor. So the C will be factored out. Now to get what's inside the parentheses, I'm going to take each term on the right side, divide that by the common factor of C. So in this case, C divided by C is 1, plus M times C divided by C. The C's will divide out, you'll be left with M. So I have C times the quantity 1 plus M. And if you want to check to see if it's correct, you can use the distributive property. C times the 1 will give you the C. C times the M will give you M times C. And now I can go ahead and get C by itself. It's being multiplied by the quantity 1 plus M, so I need to divide both sides by the quantity 1 plus M. So now C is equal to, not going to be able to simplify that, I just have to write it as P over 1 plus M. And that's as far as I can go with that problem. Okay. All right, here's some additional examples. I got like 5 of these, and these might be similar to the ones that are in the homework. And it says here, when 5 times a number is decreased by 4, the result is 26. What is the number? Okay. So here, we're going to let X be the number that we're looking for, because the question does ask, what is the number? So that's what we want to find. So we're going to let X be the number. Now I'm going to translate that sentence into an equation. We have 5 times a number. That would mean 5 times X is decreased by, meaning subtraction, and then 4. The result is, that's going to be the equal sign, 26. So here's the equation, 5x minus 4 is equal to 26. And here I want to find out what that number is going to be. Okay. So now to solve for x, or to get 5x by itself, I'm subtracting 4. I need to add 4 on both sides. So that means I'm going to have 5x is equal to 30. And to get x by itself, I'll divide both sides by 5. That would give me x is equal to 6. And if I want to check, I use the original problem, not the equation itself. 5 times the 6 will give me 30. If you decrease 30 by 4, you'll get the result of 26. So that means x equals 6 is the solution to that word problem. That is the number that we're looking for here. All right, problem number 2. When a number is decreased by 20% of itself, the result is 20. What is the number? Okay, so we're looking for the number, so that means we're going to let x be the number. We'll let x equal the number. And we're going to translate that into an equation. When a number, that's going to be x, is decreased by, that's subtraction, 20%. But what's 20% as a decimal? 0.20 of itself. Of means I need to multiply x. The result is 20. That's your equation. Okay. So now let's simplify this or solve this equation for x. That x is like a 1x. So if I do 1x minus 0.20x, or think of money, $1 minus 20 cents will leave you 80 cents. So that would be 0.80x equals 20. And then divide both sides by 0.80. That would mean x is equal to probably the first time in this video that I had to use a calculator is 25. So if you want to check this, we got 25. That's going to be decreased by 20% of itself. Well, 20% of itself will be 5. And 5 from 25 leaves you 20. Yes. So x equals 25 is the number we're looking for. Okay. All right. Next problem. When 60% of a number is added to the number, the result is 192. What is the number? Okay. So again, let x be the number that we're looking for. And now we need 60% of the number. 60% as a decimal will be 0.60. Of means multiply the number, which is x, and that's added to the number that we're looking for. That's x. That result will equal 192. So here's our equation. 0.60x plus x equals 192. And again, that x here is like a 1x. So if we add 60 cents to $1, that would be $1.60. So it'll be 1.60x. When we combine like terms, that's equal to 192. And then to solve for x, we'll divide both sides by 1.60. That means x is equal to 192 divided by 1.60. I'll end up with 120. So x is equal to 120. And that makes sense. So if I take 60% of 120, 0.60 times 120, that would be 72. And then add 120 to the 72, you'll get 192. So x equals 120 is that number we're looking for. All right, here's another example. Now this is probably something you've probably seen when you're doing percent problems in one of your earlier math classes. 70% of what number is 224? 70% of what number is 224? But here we're going to let X be the number. %, as a decimal will be 0.70. Of means to multiply, and X is the number we're looking for. Is the equal sign, 224. So you got 0.70X is equal to 224. And then to solve for X, you just simply divide both sides by 0.70. So your X is equal to 224 divided by 0.70, and you'll get 320. And I'll leave the check with you. Because if you do 0.70 times 320, you should get 224. And then finally, one number exceeds another by 26. The sum of the numbers is 64. What are the numbers? Okay. We're going to let X be, and I'm going to say X is just going to be the first number. The first number. All right. Now, one number exceeds another by 26. If it's exceeding the first number by 26, then that would be X plus 26, which is the second number. And the sum of the numbers is 64. What are the numbers? Okay. Well, the sum means I need to add the first and the second numbers together. The first number is represented by X, plus the second number represented by X plus 26 equals 64. So here we're going to find what those numbers are. Okay. Now, again, this is 1X plus another 1X, that's 2X plus 26 equals 64. So now to get 2X by itself, I need to subtract 26 on both sides. This will mean that 2X is equal to, I think this is 38. Let me check. Yeah, 2X is equal to 38. And then to solve for X, I'll divide both sides by 2. That means X is equal to 19. Now I'm going to stop right there because X equals 19. That's just the first number. The question is, what are the numbers? So I need to find the first. I found the first number. I also need to find out what the second number is. Well, the second number is represented by X plus 26. So if I do 19 plus 26, this will give me 45. So that means the second number is 45. And if I add the two numbers together, 19 and 45 together, that sum does give me 64. Okay. So the two numbers are 19 and 45. Okay. All right, so this will conclude this video on section 1.3 dealing with models and applications. Feel free to do the homework. Feel free to ask questions if you have any questions about the homework or anything presented in this video.